we can configure the ACL. We can use the access control list to filter the prefixes. ACL, access control list, can not only be used for the traffic filtering. ACL, access control list, can be used for traffic filtering, and ACL can be used for data filtering, and ACL can also be used for route filtering. ACL can be used for traffic filtering, and ACL can be used for route filtering as well. ACL can be used in other places as well, such as we can use the access control list under the line VTY, so that we can control who can telnet, who can SSH. That thing can also be done. A lot of places ACL can be used. When we configure the ACL for data filtering, we configure it under the interfaces. When we configure the ACL to control who can telnet SSH, we can configure it under the VTY lines. And when we need to configure, we need to perform the route filtering for route filtering. When we need to use the ACL to perform the route filtering, we need to apply it under the routing protocol. When we need to filter the prefixes, using the access control list, we need to apply the ACL under the routing protocol. Now, as you must know, ACLs are of two types. We have two types of ACL. We have a standard ACL. We have a extended ACL. We can use both of the ACLs to perform the route filtering. However, most common type of ACL that we use to perform the route filtering is the standard ACL, and most common type of ACL that we use to perform the data filtering is like the extended ACL. Because extended ACL gives us way too much options to perform the filtering based on different criteria. So very popular technique to perform the data filtering, and the standard ACL is very commonly used to perform the route filtering, but both can be used for both of the tasks. We can use the standard and extended ACL to perform the data and route filtering as well. You must know already that when it comes to the standard ACL, the only criteria that we can use to match the prefixes is the source IP. But when it comes to the extended ACL, we have like a lot of options based on which I can match the packet. So we have the source IP, destination IP, source port, destination port, protocol number, protocol name, different types of things are there. So let's say we want to filter the prefixes. We want to perform the route filtering. Remember that with the help of the ACL, we cannot actually do the route, we cannot influence the route. It will just be filtered. We cannot like influence that, okay, this is primary, this is secondary. We cannot do that with the help of ACL. It will just filter. So when we are using the standard ACL, to perform the route filtering, how we are going to use it? A standard access control list to perform the route filtering. Remember that a standard access control list can be created by number, or a standard access control list can be created by name. There are two approaches that we can configure: the standard or extended ACL, numbered approach, named approach. These are some things from your CCIE studies, and also numbered ACL, named ACL, and all that. So let's see how we can use the standard access control list to filter the routes. Let's say, for example, on router number 3, I want to receive only and only 120 prefixes, and I want to receive only and only 130 prefixes. Rest I want to filter. On router number 3, I want to only and only receive these prefixes, and rest of the prefixes I do not want to receive. Rest everything like I want to deny. The task is to filter the prefixes on router number 3, and you should only receive 120 and 130 prefixes. Rest you have to deny. So when we configure the access control list on router number 3, how we do this? We go to router number 3, we use the keyword access list, and we specify the number of the ACL. If we specify the number 1 to 99, it will be the standard ACL. Or if we specify the number 1300 to 1999, it will also be the standard ACL. It is the expanded range for the same. We can choose any number such as 50. And here we need to specify permit. Permit means match, allow. I want to allow these prefixes. Whatever prefixes you want to allow, you permit them in the ACL. Whatever prefixes you don't want to allow, deny them in the access control list directly. Remember that we are going to use this ACL directly to perform the route filtering. I am not going to use this ACL in the AD value. I am going to use this ACL directly to perform the route filtering. So in the ACL, whatever you want to allow, permit it. Whatever you want to deny, deny it. So access list 50 permit. And what do you want to permit? Exactly what do you want to permit? Here you have to write down a network ID and subnet mask in such a way that matches the desired range. Here you have to write down a network ID and a wildcard mask in such a way that it matches 120.1.0.0 to 120.1.5.0 and 130.1.0.0 to 130.1.5.0. You have to write down an access control list, network ID and wildcard mask in such a way that it matches the prefixes from this range. So we can use the access control list, we can use the ACL, we can use the standard ACL, either named or numbered. Remember that the standard ACL can only do the filtering based on the source. So in the source IP, when we write down the ACL, access list deny, and here we specify what prefixes we want to allow or what prefixes we want to filter. So in the source, we specify like what prefixes we have to filter, what prefixes we want to allow, what prefixes we want to not allow. For example, let's say we want to filter the prefixes from this range to this range, like 7.7.0.0 to 7.7.7.255. Let's say we want to filter the prefixes from this range. I do not want to receive any prefix from this range. So I have to write down a network ID and wildcard mask in such a way. I have to write down a network ID and wildcard mask in such a way that it matches and filters all the prefixes from this range. How that can be done? To do that, just to revise all your ACL concepts from your previous studies, what you need to do, what we do actually, we write down this range into binary. We are going to see 7.7.0.0, 1, 2, 3, 4, 5, 6, 7. I'm going to write down these addresses into like this, and then I'm going to write down the binary of that. Basically, what we need to find out, that if we want to match all these prefixes, if we want to match all this range, if we want to match this range, then what network ID should I write? If I want to match all these prefixes, what in the access list 1, what network ID should I have to enter? So we need to find out the network ID that can represent all of these prefixes. Basically, we need to find out the part that is common. We need to find out the part that is common in all these prefixes, because the common part in a range is what we refer to as the network ID. By the definition, what is the network ID? Network ID is the IP address where host part is completely 0. Network ID, by the definition, is an IP address where the host part is completely 0. In a set of prefixes, network ID is the part that is common. Network ID is the part that is common in all the prefixes. Network part in this range, the network part is the part that is common in all these prefixes. Whatever bits, whatever number of bits are common in all these prefixes, we have to consider that part as the network part, and remaining part that is changing, we need to consider it as the host part. And to write down the network ID, we have to write down the network part as it is, and the host part we have to put all 0. Network ID, by definition, network ID is an IP address where the host part is completely 0. So this is the range that is given to me. In this range, we need to find out what part is the network part and what part is the host part. How can we find out the network part and the host part? The part that is common in all the IP addresses, that is what we refer to as the network part. and the part that is changing in all these IP addresses is what we are going to refer to as the host part. So how to find the common part, how to find changing part, convert these into binary. So I can see clearly that 7.7 is same everywhere. That is why I did not write down the binary for the same. So I just write down exactly like that. I can see that the changes are happening in the third octet. So I write down the third octet in the binary. I write down the third octet in the binary. And in the third octet that is written in binary, I do not care about the fourth octet because fourth octet could be anything. So since the changes are happening in the third octet, I need to worry about the third octet. So here you can see that if you write down this third octet in binary, you can find out that first 5 bits, the first 5 bits are exactly the same. 0, 0, 0, 0, 0, 0, 0, 0, 0, all these are same. And it is the 6th, 7th, and 8th bit where the changes are actually happening. So in all the IP address, whatever part is common, this part is common. This part is common in all the IP addresses, and this part is the part that is changing in all the IP addresses. So I have to write down this common part as it is 1, 2, 3, 4, 5. I have to write down this common part as it is, and the part that is changing, the part that is having different values. That this part is I'm going to consider as the network part, and this part, the last part, is what we are going to consider as the host part. And if I want to write down the network ID, the host part should become all 0. So first of all, I'm going to write down the given range into binary. First of all, I'm going to write down the given range into binary. Then I'm going to find out how many bits are exactly the same. The number of bits that these bits that are these part that is exactly the same, it is what we are going to consider as the network part. And the part that is changing, like last bits, these are changing, we are going to consider that part as the host part. And to write down the network ID, this part is the network part, this part is the host part. So to write down the network ID, host part must become all 0. So I put the network part as it is, I put the network part as it is, and I put the host part as all 0. So the result came to be 7.7.0.0. This is going to be the network ID. If you have any other way of calculating the network ID, you can try that. But we need to find out the network ID. We need to find out the common part in all these IP addresses. And now we have to write down that common part as it is. And the part that is changing, we are going to consider this as the host part, and we are going to put all 0 in that place. And we are going to get the network ID. So network ID of this given range, network ID for this given range is going to be 7.7.0.0. And now we need to write down the wildcard mask as well. So how can we find out the wildcard mask? The part that is common. Wildcard mask basically is to tell the access control list what part of the IP should match, and what part of the IP you do not care. I need to tell the router that if you are receiving a prefix, if you are receiving a route information, and that route information has the first octet as 7, match it. Second octet as 7, match it. In the third octet, if first 5 bits are 0, 0, 0, 0, 0, then the packet will be considered as match. And rest like part, I do not care. So I need to tell the operating system again, I need to tell the iOS what part of that prefix must match, and what part of the prefix I do not care. So as we can see that in this given range, this part must match and this part is don't care. So you have to write down the wildcard mask. To calculate the wildcard mask, consider the network part as the must match and the remaining part as the don't care. Must match is in wildcard mask is represented by 0, and do not care is 1. So first octet must match, second octet must match, third octet 5 bits in the third octet must match. So 0, 0, 0, 0, 0, and I do not care about the 6th, 7th, or 8th bit of the third octet, and I do not care about the last octet. So the wildcard mask is going to become 007.255. So if we need to match that range, this is the network ID and wildcard mask you can write down. Similar to that, we have to match only 5 prefixes. Unfortunately, you cannot do that. You cannot just match 5 prefixes. You just cannot do that. You cannot match just 5 prefixes. There is no way you can match just 5 prefixes by using that statement. You just cannot do that. Remember that range can never be random. It can never be random. Range will always be in 2 raised to the powers. The range will always be either like 1, 2, 4, 8, 16. There is no number 5 here. We cannot unfortunately match the prefixes exactly 130 or 120. We cannot match it like 130.100 to 5 we cannot match, or 0 to 5 we cannot exactly match. But anyway, access list permit, I need to write down 120.1.0.0, 0.0.7.255, and access list 50 permit 130.1.0.0, 0.0.7.255, and access list 50 permit any, deny any. So I have configured an ACL. In that ACL, whatever prefixes I want to match, permit. Whatever prefixes I don't want to match, deny. Write down the range that is given to you in binary. Write down the range that is given to you in binary and try to find out the network ID and wildcard mask that represents the entire range. And the approach to find out the network ID and wildcard mask is like that. Write down the entire range that is given to you, convert it into the binary, and see how many bits are matching and how many bits we don't care. Whatever bits are matching, you have to write down them as it is, and whatever bits are don't care, just set all 0 in that. Done. This is how we can configure the access control list that matches our desired prefixes, and after matching the desired prefixes, it is going to allow or deny the prefixes accordingly. Any doubts? If you have, let me know. There could have been another way, like you write down the network ID and subnet mask that represents this entire range. You can write down the network ID and subnet mask that represents this entire range, 7.7.0.0 to 55 to 48.0. Finding out the subnet mask is very easy. Like first octet, network part, network part in the subnet mask is represented by 1. So 255, and then 1, 2, 3, 4, 5, which is going to be 248. So the another way could have been like write down the network ID and subnet mask that represents the entire range, and then convert this subnet mask into the wildcard mask. To convert the subnet mask into the wildcard mask, all you need to do is to basically subtract it from all to 55. The result will be the same, 0007 to 55. This technique might not work always. That's why we generally do not use this, but it could also be one way to write down the network ID and wildcard mask. This technique sometimes does not work exactly like intended. So, and then this is how we can configure the ACL. And now if we want to apply it, how can we apply it to perform the route filtering? We need to go to the routing protocol, such as router OSPF, router EIGRP, or router RIP, whatever. And we need to use the command called distribute list. Distribute list is the command that we need to use. Distribute list is the command that we can use to actually call this access control list to perform the route filtering. Distribute list number 50. 50 basically means the ACL number. Distribute list 50. Distribute list 50 basically means that I am going to use the ACL number 50 to perform the route filtering. Same command we can use under the EIGRP, same command we can use under RIP. The command is distribute list number 50 and then in. In means incoming updates, out means outgoing update. In means when we receive the update we are going to filter, Out means when we advertise the updates, then we are going to filter. At the moment, we want to filter all the prefixes that I am receiving. So the command is distribute list 50 in. The command distribute list is going to filter the prefixes based on the ACL. Distribute list is the way, distribute list is the command that we use to filter the prefixes that we use to call the ACL that we have just configured. Just like in case of data filtering, just like in case of route filtering, data filtering, there we use the command IP access group. Here we use the command distribute list. Okay, and you check do show IP route OSPF. You can see that only 120 and 130 prefixes should be there. Only 120 and 130 prefixes should be there. So 120 prefixes are there. I'm not receiving 130 prefixes. Were I receiving 130 prefixes earlier? Let me cross check. Yes, we were receiving 130 prefixes as well. 130.1.0.0, that is fine. Those prefixes should be here as well. To show run pipe section router OSPF. So the command is router OSPF, router ID, distribute list 50 in, and do show IP access list number 50. So 120.1.0.0 wildcard mask, it is okay. 130.1.0.0 and the wildcard mask is okay as well. And then permit any 130 prefixes, we can cross check 130.1/24. Yeah, it's okay. Let me cross check again if I'm receiving the prefixes on the other routers or not. Let's see on router number 5, am I receiving those 130 prefixes or not? Yes, here we are receiving those prefixes. So let me do one thing. Let me go to router number 3 and let me try to clear this OSPF process. Clear IP OSPF process. Anyway, this command is going to allow, this command allows you to filter the prefixes based on the ACL. Distribute list command is what we have to use. This distribute list command is going to filter the prefixes as per your requirement. So like first you configure the ACL. In that ACL, you define what you want to permit, what you want to deny, and then you apply that ACL with the help of the distribute list. It should actually show IP route OSPF. It should show you 130 prefixes as well. Okay, configure terminal. Do show IP access list. Doesn't look like the 130 prefixes are matching here. Neighborship is okay. Do show run pipe section. Do show IP protocol. So it says that incoming update filter list is 50. That is fine. So show run pipe section router OSPF. Do show run pipe section router OSPF. That is okay. Distribute list is also okay. And do show IP route OSPF. I am receiving all those prefixes, but I'm not receiving 130 prefixes. On router number 8, let me do one thing on router number 8. Do show run pipe section router OSPF. Let me remove this and apply it again. Let's see what happens. Let me remove this redistribute command and apply this again. Redistribute RIP subnet. Let's see what happens now. LSAs are there, as I can see, 130.1, 130 looks okay. So do show IP access list. It's somehow it's not matching in here. ACL is correct. 130 dot, not sure what is the no access list 50. Again, access list 50, then permit 120.1.0.0 and access list 50, permit 130.1.0.0 and access list 50, deny everything else. Still, it's not matching those prefixes. Okay, it could be because we have configured NSSA here. Let me do one thing. Let me remove this NSSA configuration from these routers. Router 7. Okay. So configure terminal, do show run pipe section router OSPF. So here I'm going to say no area to NSSA, and same command I'm going to use everywhere else. Router 5, I'm going to use the same command. Router number 7, I'm going to use the same command. And router number 8, I'm going to use the same command. No, it's still not sure what is the issue, because ACL is applied correctly, 130 subnet is there, and same thing I can confirm the routes that are here, and then 30 prefixes are here itself. It should filter. Not sure why it's not filtering. Let me do a clear as well, clear IP OSPF process. Check it again. Show IP route OSPF. Now it's there. Not sure what was the issue. Those prefixes are now it's okay. Now it is fine. So might have been some problem. ACL was not matching those prefixes due to some reason, but now the ACL is matching those prefixes. As a result, we got all those prefixes in the table. Might be some issue. You can try once in your lab as well. So the point is that when we configure this ACL, when we configure this access control list, in the ACL directly we need to specify. In the ACL directly we need to specify what prefixes we want to permit and what prefixes we want to deny. Whatever prefixes we permit are going to be permitted. Whatever prefixes we deny are going to be denied. And based on that, you will receive the routes in the routing table. So first configure the ACL, then configure pipe section router OSPF, then configure like router OSPF, configure the distribute list and everything. And then you should see the filtering will happen exactly based on the ACL that we have configured. Whatever we have permitted in the ACL is allowed. Whatever we have denied in the ACL is denied here. Okay. Now this command that we have applied, this command is going to filter the prefixes on all the interfaces. We can also mention that I don't want to filter anything on FA 0/1. I only want to perform the filtering on 0/0. So instead of configuring this, I could have done this as well. I could have said like distribute list 50 in and the interface FA 0/0. I can also mention the interface after that. It means that I am going to filter the prefixes, but only on this interface. I am going to perform the route filtering, but only on the interface FA 0/0. So instead of just configuring the route filtering on all the interfaces in a generic way, we can perform the route filtering on one specific interface as well by mentioning the command, by mentioning the interface after the command. And we can now say do show IP route OSPF. We can see that on FA 0/1, 2/0, everywhere I'm receiving everything. On everywhere I'm receiving everything, but on FA 0/0, we are not receiving these prefixes. We are not receiving prefixes other than these one. On FA 0/0, I'm going to receive like these prefixes, and I'm going to deny everything else. But on rest of the interfaces, I'm going to receive everything. You can see that 130 and 120 they are available on 0 by 0, 0 by 0, but on all the rest of the interfaces, all the prefixes are being received. So we can also mention that I do not want to filter the prefixes on all the interfaces. I want to filter the prefixes on some specific interface. That thing can also be done. So we have options. We have one option. We have one option that we can filter the prefixes. We have one option that we can filter the prefixes on all the interfaces in general, or we can filter the prefixes on some specific interface. Similar to this, we can mention out. Out means I am going to receive the prefix, but when I advertise the prefix to the neighbor router, I am going to perform the filtering. Out means out, like when I send the update out of all the interfaces, I am first going to filter the prefixes based on the ACL. Or if we have mentioned out any specific interface, that means if we want to filter, if you are going to, when you advertise the prefixes out of that specific interface, then only you are going to perform the filtering. So just like in interface, similar to that, we have out interface as well. In interface and out interface command is there as well. Remember that in OSPF, applying the distribute list in out direction will not work, because this distribute list is going to filter the routes. And again, OSPF does not advertise the route. OSPF advertises the LSA. So this command does not work in OSPF in out direction. This will just not work. Distribute list 50 out, this will just not work. This command will just not work in OSPF routing protocol. In other protocols, it will work, but it will not work in the OSPF routing protocol. Why it will not work in the OSPF routing protocol? It will not work in the OSPF routing protocol because in OSPF, like LSAs are advertised, not the routes, and this command filters the routes, not the LSAs. So we have the options now. You can see we have the options: distribute list in interface, out interface. We have the option, and you can keep changing the ACL as per the requirement. You can keep changing the ACL. You can add the entries in the ACL. You can remove the entries in the ACL. You don't need to apply the again and again in the distribute list. Changes can be made in the ACL as required. We don't need to apply the ACL again and again in the distribute list. And to verify if the filtering is done or not, we can use the command show IP protocol, and there we can verify if the filtering is being done or not. Again, let's say another example. Let's say we want to filter these 4 prefixes this time. Another example, let's say we want to filter these 4 prefixes. 7.7.4, 5, 6, 7. We want to filter only these 4 prefixes. So I'm going to write down these 4 prefixes in binary. I'm going to see what part of these 4 prefixes is common, because that part I'm going to consider as the netter part, and that must not change. That must be written as it is. So I saw that 7.7 is common everywhere, and in the third octet, 1, 2, 3, 4, 5, 6 bits are same. So I will write down 7.7.000.001. Whatever it is, I'm going to write down as it is here. So this part is going to be considered as the network part. And the remaining, because this part is common in all the IP address, all the IP addresses that we have to match, this part is the common part. So that part will be the network part, and the remaining part is going to be the host part. And as per the definition of the network ID, the host part must be all 0. So I have written down the network part as it is, and I have written down the host part as all 0, because as per the definition of the network ID, the host part should always be 0. So if I convert it into the decimal again, it will be 7.7. And this is written as 4. 100 is equal to 4. So the network ID will be 7.7.4.0. And the wildcard mask 0.0.1234567 8 and 1111, so 255. So the wildcard mask is going to be 0.0.3.255. So the ACL will be 7.7.4.0, 0.0.3.255. You can apply the same logic for your 120 prefixes. You can apply the same logic for 130 prefixes. You can apply the same logic for any subnet that you want to match with the help of the access control list. We can also apply the distribute list in one direction. Now, so we have the command distribute list one in. We have the command distribute list one in on interface. We have the command distribute list one out. We have the command distribute list one out on a specific interface. In means incoming updates are going to be filtered. In interface means incoming updates are going to be filtered on a specific interface. Out means outgoing updates are going to be filtered on all the interfaces, and out interface means outgoing updates are going to be filtered specifically on this particular interface. Also remember, we cannot apply more than one ACL in one direction. Like we cannot say distribute list one in, and we cannot say like just below that we cannot say distribute list two in. We cannot say that. In one direction, one ACL will be applied. That rule is still applicable in the route filtering as well. This rule is also there in the traffic filtering, that on one interface we cannot apply more than one ACL. That rule is still applicable on here as well. That means distribute list one in. That means now we cannot apply distribute list two in. Distribute list one in on interface, we cannot apply distribute list two in on the interface. On one direction, we can apply one. You can do that. Distribute list two out, distribute list three out on interface. You can do all that, but you cannot apply multiple ACL in the same direction. That rule is still applicable. Any doubts if you have, let me know. Any questions if anyone has, let me know. Any question if you have, you let me know. Not only that, see, we can apply in, we can apply on normal, we can apply in, we can apply in interface. We can also do this. Let me show you. We can also do this. See what I'm doing. Access list 50 permit 120.1.1.0 or access list 150, access list 50 deny 120.1.0.0, 0.0.7.255, and access list 50 permit any. Then access list 60 deny 130.1.0.0, 0.0.7.255, and access list 60 permit any. I have configured two ACLs this time. One, I am going to configure like the command distribute list 50 in, and the second I'm going to configure distribute list like 50 in and on a specific interface like 2x0. It is completely possible. Sorry. It is completely possible that we can apply one ACL for all the interfaces, and we can apply one ACL specifically on that particular interface. Do show run pipe section router OSPF. We have two ACLs now. We have two ACLs applied here. One ACL that is applied here is the distribute list 50 in, and the other ACL that is applied here is the distribute list 60 in on a specific interface. What does it mean? It means that when the update will arrive on the interface, it will be filtered by this, and in general on the rest of the interfaces it will filter with this. Actually, it's not like that. Do not think that this command is going to filter the prefixes specifically on the interface FA2x0, and this command is going to filter the prefixes on all the rest of the interfaces. It's not like that. This command basically means, see, on all the interfaces, first ACL number 50 will be applied to filter the prefixes. On all the interfaces, ACL number 50 will be applied to filter the prefixes. And then specifically on the interface, the prefixes are also going to be filtered with the ACL number 60. That means on FA2/0, filtering will be done by two ACL, 50 and 60. See, show IP protocol. Here, incoming updates on all the interfaces will be filtered by ACL number 50, and interface FA2/0 will be filtered by 60 as well. So see, so first of all, on all the interfaces, the ACL 50 is going to perform the route filtering. And what do we have denied in the ACL 50? So IP access list number 50, we have denied 120 subnets. That means 120 subnets will not be available anywhere. On all the interfaces, we have filtered this subnet. So do show IP route OSPF pipe, pipe include 120.1 subnet is nowhere. This 120 subnet got filtered everywhere, right? 120 subnet got filtered everywhere, and the rest of the prefixes were allowed. Rest of the prefixes means everything other than 120 is now allowed, and allowed on all the interfaces. And when the prefixes are received on FA2/0, additionally, the ACL number 60 is going to perform the filtering as well. That means on FA, show IP route OSPF pipe include 130.1 subnet, you can see those prefixes only and only on 0/1. You do not see those prefixes on here. Otherwise, if only one ACL was being applied, then 130 subnets you should have received on here as well as here. Because as per the ACL number 50, I am going to block 120 and allow everything else, but that doesn't look like the condition. The 120 prefixes are filtered on all the interfaces, and 130 prefixes got filtered on the interface FA2/0. Then the rest of the prefixes got installed in the routing table. As you can confirm, we do have the prefixes in the routing table, but after the filtering that is done as per our requirement. So 120 subnet is not there anywhere, and 130 subnet got filtered on this interface as well. This right here. Here. We can apply like multiple ACLs as well. We can apply multiple access control lists here as well. On one router, we can apply an ACL. That ACL says, I'm going to deny these prefixes, permit everything else. And this ACL says, I'm going to permit these things. So I can apply the ACL on this specific interface, and then we can apply in general on all the interfaces as well. It is completely possible to apply multiple ACLs, but not in the same direction, in the different direction. Only one ACL in one direction. Doubts, let me know. You can configure instead of configuring the numbered ACL, you could have configured the named ACL, show IP access list. You could have said like configure terminal, IP, access list, standard, Cisco, then permit 120.1.0.0, 0.0.7.255, permit 130.1.0.0, 0.0.7.255, and then deny everything else. And then router OSPF1, distribute list, the name of the ACL, and either in direction, out direction, in on interface, out on interface, we can also apply the named ACL. And you see, as soon as you apply that named ACL, the previous ACL got removed. So we cannot apply multiple ACL at the same time. So you could have configured a named ACL as well. Standard ACL is just going to filter. The standard access control list is just going to filter the prefixes based on IP address, like source IP address. And in the source IP, we need to specify the prefixes that we want to filter. No matter if it is a standard, extended, does not matter what type of it is, like named or numbered, does not matter what type of it is, can be applied exactly the same way. This is how we can perform the route filtering using standard access control list, either named or numbered, in interior gateway protocols. Any doubts if you have, you let me know. Now, same can be done with the help of extended access control list. However, the extended access control list can match based on two things. Extended ACL can match based on two things. In the extended ACL, we have to specify source as well as the destination. Remember, we are talking about IGP protocol. When we talk about BGP protocol, this works very differently. So we are just talking about IGP. When we want to perform the route filtering using the extended access control list, in the extended access control list, we can match both source and destination. We write down the access control list where we need to match the source and the destination. So while creating the extended access control list to perform the route filtering, in the source, we match from where we are receiving the update. Routing update source means source IP. Source IP of the update message. From where you are receiving the. Earlier, we were doing that by mentioning the interface. Like we no longer need to mention the interface now because we can specify it directly on there. So in the source, we need to match the routing update source, and in the destination, we need to match the prefixes that we want to filter. So for example, again, let me remove the ACLs that we have applied on the OSPF. So here, I'm going to remove this distribute list, and I'm going to remove the other distribute list as well. Let's try it in other protocol, any other protocol. Let's say, for example, EIGRP protocol, router 11 maybe. So I am receiving all the prefixes again, as usual. I'm receiving all the prefixes. Do, show, run, pipe section, router EIGRP. Let me remove that distribute list that we have, distance that we have configured. So on router number 11, I am receiving all the EIGRP prefixes. On router number 11, I'm receiving all the EIGRP prefixes, as you can see. On both the path, I'm receiving all the EIGRP prefixes on both the path. I do not want to receive any prefix from this path, only and only this path. And I want to use ACL for the same. I do not want to receive any of these prefixes from this path. I do not want to receive any of these prefixes from this path. So configure terminal, access list 150, deny IP, host. Why the host keyword? Because I want to match a specific IP address, a specific source I want to match. So host, otherwise you could have used the 000 wildcard mask as well if you did not use the host keyword, completely your choice. So access list 150, deny. I want to deny prefixes from this host, and then in the destination part of it, I want to mention the prefixes 120.1.0.0, 0.0.7.255. Access list 150, permit IP any. This ACL says deny these prefixes from this source, deny these prefixes from this source, and then permit all the other prefixes from all the other sources. And then apply this exactly in the same way. Distribute list 150 in interface and whatever you want to apply, you can apply the same, exactly the same. Access list 150, deny IP host, then access list 150, permit accordingly, and then you can just check the routes, do show IP route EIGRP. You can see all those prefixes are gone from 100 subnet. They are now being received only from there. You can check, do show IP access list, that your ACL is matching the prefixes properly. 5 prefixes got matched and filtered. So when it comes to the extended access control list, we have 2 things to specify. One is the source, one is the destination. In the source part of the extended ACL, we need to match the source from where we want to do the filtering. And in the destination part of this extended ACL, we need to match the routes that we want to filter. So we want to filter these routes from this source that we have specified and permitted everything else, and then applied it exactly the same way as we applied the standard ACL. We do not need to mention the interface here because anyway we are mentioning this thing here. So no need to mention the interface. You can configure the named ACL as well. Do it yourself. You can configure the named extended ACL as well, completely exactly the same way as we did for the numbered one. So do it yourself. And that's it. This is how we can use the extended ACL, either named or numbered, to perform the route filtering in interior gateway protocol. Also remember that if you have removed the access control list, if you have deleted the ACL, but you did not remove it from the router EIGRP, for example, router OSPF, for example, you have deleted the ACL. You have deleted the ACL, but you have not removed the ACL from the protocol configuration. That ACL will not have any impact. Means that all the routes will be available. So this does not make any sense if you have not created that particular access control list. This is how we can use the access control list to filter the prefixes as per our requirement. We can use the ACL to perform filtering. We cannot do path manipulation. It will just filter. It will either permit or deny the prefixes, and that's it. ACL will just filter, just pure, like in the distribute list when we have used the ACL, it will just purely filter the prefixes. It will not do the path manipulation or anything. It will just filter it. In case of AD, we had the option to either filter it or do the path manipulation as per the requirement. But in the ACL, that's not the condition. It will just filter it. Use the standard ACL or the extended ACL, named or numbered, completely your choice. Now, this is very basic matching. This is very basic matching that we have done. We can also do some complex matching in the access control list. We can do some complex matching with the help of the ACL as well. So let's say on router number 9, let me configure 2, or router number 10, let me configure 2 loopbacks. Now, interface loopback 10, IP address 1234, IP OSPF1 area 3, interface loopback 11, IP address 4321, and IP OSPF1 area 3. I have configured 2 loopbacks on router number 10. One is 1234, second one is 4321, and both are part of the area 3. That means if I go to router number 3, for example, I must see these prefixes to IP route OSPF. 1234, as you can see here, 1234 is here, and of course I should have 4321 here as well. The requirement is you only need to permit these two, or you only need to block these two and allow everything else. You need to match. You need to match in the ACL 1234 and 4321. You might think that this actually cannot be done, but it can be done. You have to write down a network ID and a wildcard mask in such a way that matches 1234 4321. So 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7. This is binary representation of the same. So here now it is going to be 1 2 3 4 5 6 7 8. 3 4 5 6 7 8. Then 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. And 1 2 3 4 5 6 7 8. You have to write down a network ID and wildcard mask in such a way that it matches these two. How to write down the network ID? To write down the network ID, whatever part is common, you have to write that, you have to write down that part as it is. Whatever part is common, you have to write down that part as it is. And then the rest of the part is going to be 0. So in these two, 1, 2, 3, 4, 5, 5 parts are exactly the same. So 1, 2, 3, 4, 5 is exactly the same. Okay. In here, 1, 2, 3, 4, 5, 6, 7 bits are exactly the same. So 1, 2, 3, 4, 5, 6, 7 bits are exactly the same. Here, 1, 2, 3, 4, 5, 6, 7 bits are exactly the same in both of the IP, as you can see. You can draw the line here for better understanding. You can draw the line here for better understanding. You can draw the line here for better understanding. You can draw the line here for better understanding. 1, 2, 3, 4, 5 parts are exactly the same. And rest of the part is changing. 3 bits here, 1 bit here, 1 bit here, 3 bit here. It is going to be 0, 0, 0, 0, 0, 0, 0, 0. Because the part that changes is considered as the host part, and host part is going to be 0 in case of network ID. Okay. What is the network ID then? What is going to be the network ID? It is going to be 0.2.2.0. Completely valid. This is completely valid. Okay. Now, the wildcard mask. How to write down the wildcard mask? The part that is same in both, it has to be must match, and the part that is changing, it will be don't care. So first bit is matching in both, second, third, fourth, fifth. These 5 bits are matching exactly the same. 6th bit is changing, so it will be don't care. 7th bit is again matching, so it will be 0. 8 bit is changing, so it will be don't care. Whatever part is same in both, 0. Whatever part is different, 1. Must match, don't care. So 1, 2, 3, 4, 5, 6, 7, don't care. 1, 2, 3, 4, 5, 6, 7, and don't care. 1, 2, 3, 4, 5, 6, 7, 8. What is this wildcard mask? This is 5.1.1.5. Might not look like any ACL that you have created so far. So let's try this. So let's go on the router number 3 maybe. Configure terminal, access list 90, permit 0.2.2.0, 5.5.1, sorry, 5.1.1.5, and access list 90, deny any. Then router OSPF, distribute list 90 in. Okay. So configure the ACL, then applied it in the OSPF. Do show IP route or show IP route OSPF. Show IP access list 90. Show IP access list 90. You can check show IP access list 90, and you can check show IP route OSPF. So ACLs are not that simple as you think. We can match any two IPs. Just remember the same concept. Whatever part is common, write down that as it is. Whatever part is changing, set it to 0. That's why I said that that rule will not always be true. That IP, subnet mask, inverted wildcard mask you will get. That is not always the case. Remember that whatever part is common in both the IP has to be must match in the wildcard mask, and the part that is changing, it will be don't care. So I compared like bit by bit, both the IPs I compared, and whatever part was common, whatever bits were common in both, I put the wildcard mask as 0, and whatever part was changing, I put the wildcard mask as 1, which gave us only those two things. Okay. Now, do it yourself. On router 3, you have to perform the route filtering in such a way that you should only receive those 120 subnets. You should only receive those 120 subnets that have an even number in third octet, and in 130 subnet, in 130 range, you should only permit those prefixes that have an odd number in the third octet. Rest, deny. We can do matching with, like in the third octet, even number, fourth octet, odd number. We can also do that. Not going to do that much. Not going to make it that complex. But in 120 range, only what 120.1.0.0 to 120.1.7.255, not the entire 120 range. 130.1.0.0, 130.1.7.255. In this range, in this IP range, from 120 range, you should only have those prefixes in your routing table that have an even number in the third octet, and you should have only those numbers that have an odd number in the third octet from 130 range. What ACL statement you will write down? You have to do it yourself. Just to give you the hint, even numbers are those numbers that can be divided by 2, and odd numbers are those numbers that cannot be divided completely by 2. In short, in even number, once we divide any even number by 2, the remainder will always be 0. And if we divide any any odd number by 2, the remainder will always remain 1. This is the hint that you have to take. So this completes route filtering with the help of the access control list. The limitation of the access control list is that the only thing that we can match on is the prefix itself. Like prefix is the only thing that we can match. We can match the range only. But maybe in my routing table, we have prefixes on different CIDR, and we want to match the prefixes, block the prefixes, allow the prefixes based on CIDR. That cannot be done with the help of the ACL. That will be done